Hello, all space enthusiasts, and welcome back to the channel. Today, we are diving into the discovery that literally shaking our understanding of our home, not our planet, but our galactical home, the magnificent Milky Way. For centuries, we have gazed at the night sky, captivated by the faint band of light that stretches across the sky itself, our own spiral galaxy. We thought we knew her well. We thought we had a pretty good map. But what if I told you that our cosmic address just got a significant update? What if our galaxy, the very foundation of our existence, is not quite what we imagined? Prepare yourself because scientists have just uncovered a secret. Hidden rings within the Milky Way, so vast and unexpected that they are forcing us to redraw the cosmic map itself. This isn't just a minor tweak, it's a monumental finding that could redefine our understanding of the galaxy formation, evolution, and even places within this spiraling cosmic dance. So, buckle up because we are about to embark on a journey to the outer reaches of our galaxy to reveal the Milky Way's secret rings. First, let us establish our baseline. For decades, our models of the Milky Way has been fairly consistent. A barrel spiral galaxy about 100,000 light years across, and that is what we know so far. Imagine a giant cosmic frisbee, and if you will, at its center, a bright, elongated bar of stars, and emanating from that several majestic spiral arms, the Perseus arm and the Sagittarius arm, the Orion arm where our sun solar system resides, and there is one more arm. So two major arms and two minor arms. All right. Surrounding this disk is a vast spherical halo of dark matter, globular clusters, and isolated stars. This classic picture, while awe-inspiring, was largely based on the indirect observations, measuring stars' movement, analyzing light from distant regions, and comparing our galaxy to the others we could observe more clearly. We understand the general dynamics of the galaxy, stars orbiting the galactical center, gas and dust fueling the star formation within the spiral arms. It was a beautiful, elegant model, refined over many years of countless astronomers. But as with all the scientific endeavors, there is always more to learn, more to discover, especially when we look with the new eyes and the new tools. And recently, those new eyes have peered into the region of our galaxy that were previously too faint, too distant, or simply too complex to fully interpret. What they found wasn't just another spiral arm or a minor irregularity. They found something far more fundamental. So, how exactly do you find a secret ring in a galaxy you're sitting inside of? It's a bit like trying to draw a map of your city while standing in its central square, unable to see whole thing from above. Astronomers rely on a clever technique and incredibly sensitive modern observatories. A major breakthrough came from the mission like European Space Agency Gaia spacecraft. Gaia primarily mission is astrometry, precisely measuring the position and distance and motions of the billions of stars in our galaxy. Imagine tracking every single person's movement in a massive city, and from that figuring out the city's overall structure and traffic pattern. What's that Gaia does? How does it matter? All the stars, etc. By analyzing the velocity and distribution of these stars, particularly those farther out from the galactical centers, scientists began to notice something unusual. Instead of a smooth, gradual decrease in star density, they found regions where stars seems to pile up, forming distinct, almost concentric pattern. It wasn't just Gaia. Other observations, particularly in the radio astronomy space, which can detect cold gas and dust, the raw material for stars, also started to hint at these structures. When you combine the precise star maps from Gaia with the gas distribution map from radio telescope, a clearer picture begins to emerge. The data suggested that that beyond the well-known spiral arms, there were at least two, possibly more, distinct rings of increased stellar gas density. These weren't fleeting phenomena; they were persistent, massive structures extending tens of thousands of light years out from the center. These secret rings weren't previously identified because they were much fainter than the bright inner spiral arms and were often obscured by dust or simply too much subtle, too much, very subtle to detect with older methods. It required an unprecedented precision and comprehensive sky survey of the by using the modern instruments to finally pull back the cosmic veil. So, what exactly are these rings made of? How do they fit into our existing understanding of the Milky Way? Essentially, these are regions of higher density, concentration of stars, gas, and dust that form a circular or at least ring like pattern. One of the most prominent discoveries in today is an inner galactical ring and a newly discovered outer ring. The inner galactical ring isn't just entirely new to the theory, but its extent and precise nature are being refined now. However, the outer ring is truly groundbreaking. It is much further out than previously thought to contain, and also contains distinct structured and features. So it has a very unique shape and size. What's fascinating is that these aren't just random clumps of matter. They appear to be dynamically stable, indicating they have been there for significant amount of time, influencing the galaxy's overall structure. They are like cosmic ripples, propagating outwards from the galactical center. Astronomers believe these rings are likely related to the density waves, similar to how the traffic jams form on a highway. Even though individual cars are moving through the traffic, these waves can compress gas and dust, triggering new round of star formation and thus creating visible enhancement in the stellar density. The precise mechanism that create and maintain these rings are still under intense investigation. Some theories suggest that they could be related to galaxy central bar, which is known to drive the density wave and can influence material far out in the disk. Other hypothesis is also there that past galactical mergers, smaller galaxies being absorbed by Milky Way, that could have sent shock waves through our galaxy, creating these concentric patterns. What's clear is that these rings represent significant organized feature that demand a revised perspective of our galactical architecture. They are not just scattered stars, they are integral components that tell a deeper story about the Milky Way, its history and ongoing evolution. The discovery of these secret rings have profound implications, touching on several key areas of astronomy. Firstly, it changes our understanding of the Milky Way, its true size and extent. If these rings are stable and also a part of the major features, then our galaxy stretches further and has more complex structures than we previously thought. This isn't just an academic detail. A larger galaxy means a more potential stars, more planetary systems, and different distribution of matter, all of which impact our model of the dark matter distribution and overall mass of the Milky Way. Secondly, these rings offer crucial clues about galaxy evolution and formation. How did the Milky Way came to be? Was it a smooth process or a chaotic series of mergers and interactions? The presence of these rings lean heavily towards a more dynamic, perhaps even violent past. They are like geological layers, each telling a story of the past event. For example, if a dwarf galaxy plunged through the Milky Way's disk billions of years ago, it could have created a gravitational ripple that manifested as these rings. Studying the properties of the stars and gas within these rings can give us precise timestamps of these cosmic collisions. Thirdly, the ring impact our understanding of the star formation and the galactical dynamics. Are these rings actively forming new stars, or are they relic of the past starburst? The answer will shed light on how gas and dust are transported through the galactical disk, what triggers the birth of new stellar generation. And finally, for those of us living on in the Orion arm, just like our solar system is, you know, we thinking we had a pretty good neighborhood map. This discovery literally redraws our cosmic address. It reminds us that even our closest galactical environment holds secrets waiting to be unveiled. It is humbling and exhilarating thought. The universe, even our little corner of it, is far more complex and surprising than we even give its due credit. So, what happens now that we have found these sacred rings? The scientific community is buzzing with excitement, and rightly so. This discovery opens up entirely new avenues of research. The immediate goal is to map these rings with even greater precision. How many are there? What are their existing dimensions? Are they perfectly circular, or are they warped and distorted? More observations from Gaia, along with new data from ground-based radio telescope and next generation optical telescope, will be very crucial. Another key area of study will be to understand the stellar population within these rings. Are the stars in the inner ring significantly older than those in the outer ring? Do they have different chemical composition? Such details can tell us about the origin of the gas and dust that form them, and whether it came from within the Milky Way or was accreted from external sources. All of these are very, very important questions. Computer simulations will also play a massive role. Scientists have built increasingly sophisticated models of galaxy formation, incorporating the new ring structures. By running these simulations forward and backward in time, they can test different hypotheses about how the rings formed and evolved. Did a specific merger created them, or are they a natural consequence of the central bar's rotation and the gravitational influence? The pursuit of these answers isn't just about satisfying scientific curiosity. It's about building a more complete picture of our universe around us. Every piece of the cosmic puzzle helps us understand not just the galaxy, but also the fundamental forces that govern the cosmos. The Milky Way, our home, continues to surprise us, proving that even our own backyard, its vast, unexplored territories waiting to be discovered. It's a powerful reminder that the universe is far more static. It is not static at all. It is living, breathing entity, constantly evolving and revealing new layers of complexity. So we begin today by asking you to consider a new cosmic address, and I hope by now you have sense of just how much more intricate, fascinating that address has become. The discovery of these secret rings within the Milky Way is more than just a new map. It's a testament to human ingenuity, the power of our scientific instruments, and the endless mysteries that universe hold. It's a humbling thought that after all these years of studying our galaxy, it still has so much fundamental secrets to be revealed. It pushes the boundary of our knowledge and inspires the next generation of astronomers to keep looking, keep questioning, and keep exploring. So, friends, what do you think about this incredible discovery? Does it change your perception of our home galaxy? Let me know in the comments below. And if you enjoyed this journey through the Milky Way's newly discovered ring, please hit that like button, subscribe for more cosmic adventures, and ring that notification bell so you don't miss out our next deep dive into the wonders of the space. Thank you for joining live. Thank you for watching. And as always, keep looking up. Universe is full of secrets just waiting to be found. See you in the next one.